Hello guys, in this video, some more interesting topics related to Redshift. So let's see what is the use case to use this. When do we use this Redshift? So you have seen already we use this Redshift for big data, right? Yeah. So you can even use this Redshift for mission critical situations, like if you want for business intelligence dashboards, business intelligence dashboards, then you can choose this Redshift. I'll tell you only the mostly using use case, mostly using use cases. And this is one place where we choose this AWS Redshift. And the another case is real-time data streaming. Real-time data streaming also, we use this AWS Redshift only for our data. And we can even use this for for predictive analysis. When do you use this? For predictive analysis also you can use this. So these are the major cases where you can able to use this Redshift. There are also multiple options which are available for us to use this Redshift. So but among those, these are the main cases where we can able to use Redshift. Let's say I have put my data under Redshift. Now I am using this Redshift as my database. Now, what is the major challenge do I face while using this Redshift? Is the major challenge we commonly face while using this Redshift is managing performance during peak usage. Whenever there is a peak usage, challenge we face is common challenge that we face is managing the performance. Managing the performance whenever we using this Redshift for peak usage time, during peak usage time. So what does it mean? Whenever multiple clients are using my database. Now this can able to provide me the response. The question here is I am having provided a cluster for my Redshift. So that cluster can, let's say it can able to process up to 100 requests. But now I am getting 1,000 requests like that. So now this Redshift can able to withstand those many requests. Of course, it will withstand. But what are the what are the cons we face? What are the difficulty we face here is late response than usual response. What happens? Since I am having less resource, what do we face? Usually, the response time will be late. It leads to what? It leads to late response than usual. So, so in order to overcome this issue, that is during peak usage time, if more customers are using my Redshift, in order to overcome this issue, we need to go for scaling of our clusters, scaling of our Redshift cluster. If I scale this, then what happens? If I scale this, then what happens is we can able to provide response to those 1,000 users as well, right? Yes. So let's see. So in order to scale, we need to know what are the possible options, right? Yes. So let's see them one by one. If you want to do scaling manually without using the services, without using the options that are provided for scaling automatically, then you can able to do this by just taking the snapshot and create a new Redshift cluster. What is that way? So what is the manual way? From the Redshift cluster, whatever you have, just take the snapshot. So by using that snapshot, you can able to create a new Redshift cluster. Now let's say I want to use whatever the advanced options which are available in AWS to overcome this scenario. So what are the ways we have? We have mainly 4 ways that are provided by AWS to scale these Redshift clusters. So let's see them. What are the 4 ways? Ways to scale, ways to scale Redshift cluster. What are the ways to scale Redshift cluster from by automation? So what are the ways to scale our Redshift cluster by options? You can say automation options. Automation options. Here you just need to provide whatever your requirements, but AWS will scale you based on your requirement. So we have actually 4 ways. How many ways? 4 ways. The first way is classic resize. Classic resize. Don't worry, I'll explain you one by one. So just need to know what are the possible scalings. Then I'll introduce you one by one. Second one is elastic scaling. First one is classic resize. Second one is elastic resize, not scaling. Classic resize, elastic resize. And third one is concurrent scaling. Concurrency scaling. And finally, the last one is Redshift spectrum. So these are the different scaling options that we have available in AWS Redshift to scale. Let us see. Let us see how to scale. That is either classic way or classic way or elastic way. So how to do this scaling by using resizing, classic way resizing or elastic way resizing. Let's see from console, AWS management console. So first you open the whatever the Redshift service you have, that you need to open from services. Then you can open the clusters. Under clusters, you can see what are the clusters that you created. Now I want to resize my cluster one. So I have opened my cluster one. There you can see under actions, you have an option called resize. Just click on that resize. Then it will redirect. You can see this, that is resize cluster. You have two types of resizes, that is elastic resize and classic resize. So based on your need, you need to choose any one of them. Let's say I choose elastic resize. Now in both of them, either you can choose elastic or classic resize. You need to provide two things. What is the node type? That is nothing but what is the instance type of your node that it need to hold, that you need to provide here, and number of nodes. So those two things that you need to provide, number of nodes you want to create and node type you want to create. Those two things you need to provide, and the type of resizing you want, that is elastic or classic. Those two things you need to provide and click on resize. Then it will create you either elastic resize or classic resize from console. Let's see what happens if you resize that. What happens in the background? What process happens? Let's say you resize it by using classic resize. Then let's see what happens at the background. In first time, in classic resize, in first option, what happens is a new cluster is created like this. After that, what this new cluster need to hold? It need to hold whatever the old cluster, that is what are the previous cluster holding data, that only it needs to hold, right? Yes. So in order to get the data from the old cluster, then what it will do is it creates snapshot from what are the old cluster you have. What does it do? It creates a snapshot. It's create a snapshot from old cluster. Whatever you have from that cluster, it creates a snapshot. So under this classic resize, what happens is at last we have already copied our data from older cluster to snapshot. Now we need to copy from here to new cluster, right? Yeah, that's what happens. That is copy of data to new cluster by redistribution. It happens by using redistribution. In which order your data is stored in new cluster, sir? As same order as old cluster. How order? In which order your data is present in old cluster? So in the same order, your data is stored in new cluster as well. So how, as it is present in the source cluster, that is the old cluster. And now, so our data is moving from old cluster to new cluster, right? Yes, our data is moved to new cluster. Now, which blocks will be moved at first? The latest version blocks, the latest blocks of data, or the oldest blocks of data? At first, the latest blocks of data are moved. The latest blocks of data are moved. So, can I say, since the latest blocks of data is moved to the new cluster, whenever user try to access, does he get the latest data with quick response? Yes. Since this new cluster is creating, while creating itself, this new cluster will accept read operation. While creating itself, this new cluster accepts read operation. So what about write, sir? Can I able to write on this new cluster while this new cluster is creating? No, we cannot able to write on this new cluster. If we do classic resizing, then we cannot able to write on this new cluster while the cluster is creating. We can able to read. So this read will provide you high performance query response compared to the old cluster, because since it is creating, right, we have less amount of data. So we got our response very faster by querying what are the less amount of data that it has. And one more thing. So in classic resize, this thing you need to remember, that is deletion marker tables. Whatever the tables which are marked by deletion in old cluster, what are the tables which are already marked by deletion marker, those won't be moved to the new cluster. So in addition to those, whatever the system logs, this old cluster contains some logs, right? Yes. So how performance is monitored? By using logs only. So whatever the logs which are present in this old cluster won't be moved to the new cluster in this classic resize. Whereas if you compare to the elastic resize, whatever the logs or whatever the deletion marker added tables as well move to the new cluster. That means what are the retained tables? What are the retained tables? Those are able to move to the new cluster. Whereas in classic resize, that won't be happen. And at last, one more point. That is how this copying happens. So how this copying happens? This copying happens by using sudo vacuum delete command. Actually, this command is run internally. We don't need to do anything here. So by using this way, this will happen. This copy will happen. So in classic resize, what are the two things that you need to remember instead of elastic resize is deletion marker tables and system logs won't be copied. I'm highlighting this point. So you can see deletion marked tables and system logs won't be moved. And in addition to this, the retain system tables, that is nothing but whatever the tables that we retain under our old cluster, those won't even move to the new cluster here. So if you compare, so let me write it here so that the difference will be clearly visible from here. So at last what happens is your endpoint, whatever the endpoint that you have to your cluster, old cluster, that will point to the new cluster from now. So what happens? Endpoint will point to new cluster. So after your whole cluster is created, then what happens is your endpoint will point to new cluster. So then from then, whatever the users, those who write, those who want to read, they can able to read from new cluster. After this endpoint creation, then only he can able to read and write. For this classic resize, user can able to do both read and write after endpoint creation. After endpoint creation. So after endpoint attaching. So after endpoint attachment, in classic resize, user can able to do both reading and writing. So till before endpoint creation, in classic resize, what happens is user can able to read only. We can able to read only. We can able to read only. We can able to perform read only operations. We can able to perform read only operations, not writing operations on your new cluster. On your new cluster, so on classic resize, on your new cluster, we can able to do both read and write after our endpoint attachment. So before our endpoint attachment, what happens? We can do only reading operation only on our new cluster. So let's see, this is the same process for resizing either in classic or elastic. So let's see the major differences between classic resize and elastic resize. So this is the elastic resize, let's say. So in elastic resize as well, the process will be same like this only, but there will be just some major changes. So in classic resize, What are the data that is moved to new cluster? The data that is moved to new cluster is table and metadata only. So what are the things that are moved to new cluster? Table and metadata only. So these are the two things which will be moved to the new cluster from your old cluster. So what are the other things? Those are what? Deletion mark tables and system logs tables won't be moved. Whereas coming to elastic resize, here we can even able to move these things. What? In addition to the table data as well as metadata, we can even able to, our data is moved. Which type of data? System logs data even moved. System logs data even moved, and retain table data also moved. Retain table data also moved to this resize table. Elastic resize. In the elastic resize option, in addition to table data plus metadata, your system logs and retain table data also move to your elastic resize, right? Yeah. Then one more additional point, if we compare it to cluster resize. So in cluster resize, what happens on new cluster? So while classic resizing on new cluster, what happens? We can able to do only read operation when till the endpoint is not created, till the endpoint is not attached to the new cluster, we can able to do only read operations. Whereas in elastic resize, we can able to perform both read and write, from, we can able to do both read and write at any time, that is while creation or else after creation. From creation to created table, from creation table to created table, we can able to do both operations, that is read and write operations we can able to do at a time. So why this elastic resize allows this, and why this classic resize do not allow this? The answer for this is, in classic resize, we can able to cancel this resize option before our cluster is created. Before our new cluster is created, we can able to cancel. Before our new cluster is created, we can cancel in middle, we can able to cancel this creation at any time. So before at any time, we can able to cancel this creation in classic resize. Whereas coming to elastic resize, we do not have that. So coming to elastic resize, we can not able to cancel this creation. We cannot able to cancel the creation of new cluster. So it won't be possible under this under this elastic resize. So since once it is once this action is done, that is the elastic resize option I have chosen. So that's why, since this is a permanent, it won't be deleted. So that's why I can able to perform both read and write operations here. But if you choose classic resize, first it will create you a new cluster for temporary basis, and then it will migrate your or move your table and metadata to this new cluster. After moving whole data only, it assumes this as permanent. Before moving, it can assume the cluster is temporary. So it assumes the new cluster is temporary. So for temporary operations, then you can able to use this classic resize. Whereas for permanent spike, then you need to choose this elastic resize. In both resize options, your data is transferred. Your data is transferred or distributed to new cluster parallelly. Your data is copied in parallel to the at the target. So your data is copied in parallel only to the new cluster. The data is copied in parallel to the new cluster. So let's see how much duration does this elastic resize take and how much duration that does this classic resize take. This classic resize will take up to hours to days. So coming to time, so this will take from hours to days. So this creation will takes from hours to days in classic resize, whereas coming to whatever the elastic resize, here it will take time within few minutes, that is at max, that is within between 5 to 15 minutes. The time duration for creating it is 5 to 15 minutes. Within 5 to 15 minutes it will take to create this elastic new cluster under this elastic resize. And one more thing, under elastic resize, what happens is, if there is a less data transfer, that means a less elasticity is needed, then it even creates new nodes under the same old cluster. So here even it creates new nodes under same cluster, where in which resizing option it will be done in elastic resize. In elastic resize, it creates new nodes. It creates new nodes under the same cluster, under the same old cluster, if required. If required, it will create the same nodes. It will create some more new nodes under the same cluster if needed. So if elasticity is sufficient for that, then it will create like that. So in how many ways do I can able to perform this resize operation? We can able to perform this resize operation by using console way that you've seen previously. And you can also do this by using Redshift API, and by using CLI also you can able to perform this scaling, elastic scaling, as well as elastic resize and classic resize, both will be done by using CLI as well. You can able to do that. So in order to execute, in order to resize your cluster by using CLI, you need to have some file, right? You need to have some file with what are the configuration that you want to do. What are the resizing option that you want to do? That is either classic resize or elastic resize that you want to provide, right? Yes. So you can save that file by using either JSON format or YAML format. So let's see how the code which is present on JSON or YAML format file. Here you can see resize cluster. So I don't even need to tell about this name. So you are specifying from this command, you need to resize the cluster. And what is this cluster identifier, sir? This cluster identifier indicates by using what name you want to identify a cluster. So that name you want to provide here. That is nothing but what is the name of your new cluster that you want to create now. So that you want to provide that name here. Then cluster type that you need to provide. Either it's a single cluster or multi-cluster. Single node cluster or multi-node cluster. If it's a single node cluster, then you don't need to specify number of nodes. If it's a multi-node cluster, then you must need to specify how many number of nodes here. And coming to node type, you need to specify obviously this, because what are the node type that you select, your cluster will be created with nodes. What are the how many nodes that you provided based on that, and what are the node type that you provided based on the node type, your cluster will be created. Inside that cluster, your slices will be created based on the node type and size of your node. So under this, you can see these are the normal options, and you can see you can even generate this skeleton. You can even generate this skeleton by using CLI command, generate CLI skeleton. So by using this generate CLI skeleton, you can even generate this skeleton in Redshift, so that you can able to configure based on your needs. You need to provide the cluster name and cluster value, cluster type. Either it's a single node type or a multi-node type. And if it's a multi-node type, then you need to provide a number of nodes you want, and you must need to provide whether it's a single node or multi-node. Here, that's a node type that you need to provide here. So in this way, you need to write the script, and then you can able to run it on your Redshift by using the either EC2 instance connecting from anywhere. You can able to do this. After creating this by using YAML script, or you can save it in YAML or JSON, then you can able to commit this at once so that your script will be run. After running your script, you must need to check your status of resizing cluster, right? Yes. So you can even check the description about status of your cluster by using the command. You can see to check the Redshift, to check the Redshift new cluster creation description, use this command. AWS Redshift describe resize cluster identifier, then whatever the cluster name, here you need to change. Here you need to change. Instead of writing this bracket, open bracket and closed bracket and cluster name, you need to provide what are the cluster that you creating. That name you need to provide. So after writing this command and in CLI and enter, then you got any one of the cluster status. So we have, these are the following possible statuses, that is none and in progress. Whenever your cluster is in progress of creating, then you got this. Whenever your cluster creation was failed, then you got this response failed. And whenever your cluster creation was successful, then it will be like this, succeeded. So otherwise, if you cancel, if your cluster is creating in progress, then you stop that, then you cancel it, then your cluster description will reach to like this, that is cluster process will reach to like this state, that is canceling state. So this is all about resizing. Actually, these are the two ways to resize. That means scaling by using resizing, that is by using elastic resize as well as elastic resize as well as classic resize. So I hope you covered all the points in this, how to create it by using CLI or else by using a console, how to check the status, and what are the possible statuses, and how either resizing, classic resize or elastic resize process will be internally happens. And in classic resize and elastic resize, what is the major differences between them? Those all will we have seen in this video. So I hope you understood this video about Redshift, resize, scaling. So thanks for watching. See you back in the next video. In that video, you'll see more about other scaling options that are available under Redshift. So thanks for watching. See you back in the next video. Until then, bye bye.